So this is number 1. Express the square theta divided by the theta square in terms of y. If y is equal to tan theta, then this must be the square y then, because y is equal to tan theta. So it should be express the square y over the theta square in terms of y. So if we know that y is equal to tan theta, so you have to note these identities that is on differentiation. So if y is here and we have the y, the s here, so if y is tan theta, so I'm using, if y is tan s, so the y, the s is sec square x, and if y is sec s, the y, the s is sec s tan s. Take note of this, is important. So we have others in differentiation, but I'm only picking the one that I need. So if one y is tan s, the y, the s is sec square s. If y is sec s, the y, the s is sec s tan s. Also note this in trigonometric identity. Note that sec square x is equals to 1 plus tan square s. So we have proved all this before. So just watch my videos on trig and differentiation. So note these identities. It will be useful to solve this question. So now let's solve. Given that y is tan theta, so I will have the y, the theta, because it's y with respect to theta. So the y, the theta will be sec square theta. Note, if y is tan s, the y, the s is sec square s. So now what we want is the square y, so I have to differentiate this again. But first, the y over the theta is equal to sec theta everything square. So generally, if you have sine n theta, this is the same thing as sine theta everything raised to power n. So that means if I have any power here, I can take it out this way. So note that. So now this is function of a function. So the square y over the theta square now. It means I'm going to differentiate this using function of a function. Go and watch my video on function of a function. So see the step. The power is 2. Write it first. So the power is 2. Write the 2 first. Differentiate what you have in the brackets. Differentiate sec theta. So you are going to get sec theta tan theta. Look at it here. If y is x is sec s, the y, the s is sec s tan s. So if y is sec theta, the y, the s is sec theta tan theta, like that. Now again, the power is 2. Write it. Differentiate sec theta. We have sec theta tan theta. Now rewrite everything in the brackets. That will be sec theta. Now subtract 1 from the power. That will be 1. So this is short method for function of a function. So watch my video on function of a function to understand better. So now this will be 2 sec square theta tan theta. That is sec theta times sec theta will give us sec square theta. And remember, in this my trig identity, I have sec square s is 1 plus tan square s. That means this will be, instead of writing this sec square s, sec square theta, it will be 1 plus tan square theta from this identity. So, and I have another tan theta outside. So with this now, according to the question, we know that y is equals to tan theta. So anywhere I see y, I see tan theta, I'll put y. So this is the same thing as 2 brackets 1 plus y square, because tan theta is y and I have times square theta, then times y, that is tan theta. So this is the same thing as 2y to bracket 1 plus y square. So I've expressed my answer in terms of y. So the correct answer is C. 2y bracket 1 plus y square. So that is number 1. So now let's see number 2. So number 2. Evaluate DDS of root s if s is 16. So first, this question, DDS of root s is like saying y is equals to root s, then find the y, the s. This is the y over the s will be equals to s raised to power half. That is, this square root of s is the same thing as s raised to power half. So the y over the s is equals to half s raised to power half minus 1. Remember, if y is equals to s raised to power n, the y over the s is ns raised to power n minus 1. So that is the power rule that we use there. So watch my video on beginning of calculus, so you understand how to do the simple differentiation here. So now dy over the s will be equals to half s raised to power minus half. So because half minus 1 is minus half, that is half minus 1 over 1. LCM is 2 from here. So 2 into 1. 1 times 1, 1. Minus 1 into 2. 2 times 1, 2. So that will be minus 1 over 2. So like that. Now this is the same thing as 1 over 2 times 1 over s raised to power half. Because of this minus, I can have 1 over. So what is s raised to power half? You can change it back to your root s. That means the y over the s is equals to 1 over 2 times 1 over root s. So you can now multiply. So this simply means the s of root s is equals to 1 over 2 root s, because 1 times 1, 1, 2 times root s, 2 root s, like that. So now this should be the answer, because we have found the ds of, which is the y ds of this is the same thing as this ds of root s. Excuse me, I'll bring the video back and the image back. So the image disappear. So now I've already showed that the s of root s is equals to 1 over 2 root s. So now that we have shown this, the question now say at s is equals to 16. So that means anywhere you see s, put 16. So the s of root s is equals to 1 over 2 times root 16. So now what is root 16? That is 4. So 1 over 2 times 4. So that means 2 times 4, 8. So the answer is 1 over 8. So that is it. So the s of this is this. Is the same thing as the y. The s of root s is 1 over 2 root s. So like that. So the correct answer is B. So I have solved that one. So the next one, number 3. So number 3. If u is equals to arc sine 3 theta, then what is the u, the theta? So take note of this again. If y is there, then what is the y, the s? So if y is arc sine s, the y, the s is 1 over root 1 minus s square. So that is arc sine s 1 minus s square. See it. So we'll do the same thing here. Now differentiate 3 theta. So you will get 3 times, as in differentiate 3 theta, you get 3 times differentiate arc sine. Check the table. So you have this. So this will be 1 over root 1 minus 3 theta square, because this s is the one we square here. So this 3 theta will be the one you square here. So take note of the trick. So we have the u over the theta is equals to 3 times 1 over root 1 minus 9 theta square, because 3 square is 9 and the theta also will carry the square. So now this is the same thing as 3 times 1 minus, let me show this, 1 over 1 minus 9 theta square raised to power half, because this root is power half. So if you remove that 1 over, this is the same thing as 3 times 1 minus 9 theta square, everything raised to power minus half. So we take it up, so it will be minus half. So the correct answer is A. 3 brackets 1 minus 9 theta square raised to power minus half. So let's say number 4. So number 4. Find the value of the YDS at points s is equals to 4 and y is equals to 2. So for the function s square plus y square is equals to 1. So to differentiate this, See the short method. Please learn the short method for the implicit. Always start with minus. Always start with minus. Now differentiate only s here. You can go and watch my video on implicit to understand the short method. So now differentiate only s. Yeah, remember this is s square. So differentiate s square, you get 2s divided by, this is y square. Differentiate y square, you get 2y. So 2 will cancel out 2. So this is minus s over y. So I've differentiate implicit. Now at s is 4, y is 2. So this will becomes minus 4 divided by 2. So this is minus 2. So the correct answer is C. That's it. So let's see number 5. So number 5. We have, in terms of the parameter t, find the y, the s. So we have y is equals to t square, y equals to t square, and s is equals to t raised to power 4. So the y over the t is equals to 2t. So that is, this 2 will come down, subtract 1 from the power, and the s over the t is equals to 4t raised to power 3, because it's t raised to power 4. So write the power 4t raised to power 3. So now the y over the s is equals to the y over the t times the t over the s. If the t cancel, it will remain the y, the s. So this is the formula we are going to use to relate our result. So now the y over the s equals the y dt. So what is the y dt? That is 2t times the t ds. But this is the s dt. This is over 1. Then the t over the x, turn it upside down. That is 1 over 4t raised to power 3. So that will be 2 times 1 over 4t raised to power 3. So 2 cancel out 2 here. So 1t will go. So my result is 1 over 2t raised to power 2. So that is the answer here. But none of the above. All the options are wrong. So that is the answer. So let's see the next one, number 6. So number 6. Now evaluate the square y over the s square at points 1, 1, meaning s, y, that is s is 1, y is 1, of the curve s cube plus y cube is equals to 2. So I'm going to use the short method of implicit again. So dy dx is minus, always start with minus. So minus, now differentiate x, that will be 3x squared divided by differentiate y, that will be 3y squared. Don't forget, watch my video on implicit to see other example to understand this method better. 3 will cancel 3, so dy over the s is minus s squared divided by y squared. But what question wants is the square y over the s square. So I have to do the square y now over the s square. So this is our dy ds. Now the square y over the s square simply means d ds of dy over the s. So this expression, the square y over the s square, means d ds of dy ds. So this becomes the square y over the s square will be equals to d ds of minus s square divided by y square. Remember, that's our dy ds, d ds of dy ds. So now we need to do this now. So this is quotient rule here. So see the formula for quotient rule: v du over ds minus u dv over ds, everything over v square. So that is what I'm using here now. So the square y over the s square now will be equals to, remember, anything you have up here is u, anyone you have down is v. So based on the formula now, v, that is y square times du ds, so that is, you differentiate this one, so that will be minus 2s, let me use brackets, minus 2s. So v du ds, differentiate s squared, that is 2s, so there is minus, then minus u, that is minus s squared, as in u, then dv ds. Remember, it's dv ds, but it's y that I have here. So anytime you differentiate that, you must have the y ds. So that will be 2y dy over ds, everything divided by v square. So v is y, so that will be y square square, like that. So now this is the same thing as minus 2s y square, then plus, because minus times minus is plus, plus 2s square y times dy ds. What is our dy ds from beginning? So remember our dy ds, so I've cancelled that, is equals to minus s square divided by y square. Remember, because that's what we have here, minus s square divided by y square. So that means I'll put this dy ds now to be that expression. So that dy ds is times, let me use brackets, yeah, instead of times. So the square y over the s square is minus 2sy square plus, so minus times minus, plus 2s square y, as in we will multiply this, times dy ds. Remember, our dy ds is minus s square divided by y square, so we've shown that. So you will notice one y will cancel out, one y there, so everything divided by v squared, that is y raised to power 4. So now this is the same thing as this square y over the s square is equals minus 2s y square plus 2, there is minus there, so because minus times plus minus 2s raised to power 4 divided by y. Remember, 2s squared times s squared is s raised to power 4, so we have 1y divided by y, everything over y raised to power 4. And remember, everything up here is over 1. So find the LCM of the up one now. So we have the square y over the s square is equals to, now find the LCM of the up one. So this will becomes y, so that will be minus 2s y cube. Remember, y, 1 in y, then y times all this, normal LCM 2sy cube, y in y 1, then minus 2s raised to power 4, then everything divided by y raised to power 4. So I actually have short method for this, the square y over the s square, but it's a derived formula, but I'm only showing it here. So the square y over the s square equals minus 2s y cube minus 2s raised to power 4 divided by y raised to power 5. So this y will come down, as in to multiply this one, and you know this power 1, so in this is you add the power. So if that y should come down, so it will add to this to becomes y raised to power 5. So now at 1 comma 1, meaning s is 1, y is 1, so the square y over the s square is equals to minus 2 bracket 1 to 1 raised to power 3 minus 2 bracket 1 then raised to power 4. Anywhere you see s and y, put 1, that's it, then y raised to power 5. So this is the same thing as the square y over the s square is equals to minus 2 brackets 1 bracket 1 minus 2 brackets 1, everything over 1. So this is minus 2 over 1, so this is minus 4. So the correct answer is C, minus 4. So let's say number 7. Number 7. a body a body moves a distance s is equals to 3t square. So the speed and the acceleration after 2 seconds along a straight line are, so now speed will be equals to the s over the t. So what is the s dt? That is 6t. That is 3 times 2, 6. Also subtract 1 from the power. So now at t is equals to 2, that is after 2 seconds. So the speed is, the s dt is 6 times 2, and that is 12. So none of the above said because no 12 is here. So take note, it is 3t squared that we have, except it is 3t cubed, and this will be 9t squared. If it is 9t squared, and I think down there is answer there, so probably the question is not square, because for the first one should not give us 12. Something is wrong. Definitely this question is not 12. The question is not square, so it must be power 3. 3t raised to power 3. So that means this is not square, it's power 3. Like that. Just like number 5 that doesn't have answer to, something must be wrong. So now if it is 3t cubed, so you have 3 times 3, 9. So this will be 9t squared. So remember, you multiply and subtract 1. So at t is equals to 2. So after 2 seconds, so the s dt is equals to 9 bracket 2 square. So that is 9 bracket 4, because 2 square is 4. So 9 times 4 is 36. So that means our speed, speed and acceleration. So speed is 36. So it remains acceleration now. So what is acceleration? It means you will differentiate 2 times. So for speed, you have the s over the t, which is 9t raised to power 2. Then for acceleration, you have to differentiate this again. That is the square s over the t square. So meaning you need to differentiate this again. So this will be 18 brackets, that is 9 times 2, 18. Then subtract 1 again from the power. So that will be 18t. So 9 times 2, 18. So 18t. So at s is equals to 2. So this will becomes 18 bracket 2. So that means the square s over the t square, which is acceleration, 2 times 8, 16. So that is 36 also. So this should also be 36. So that means none of the above in that case, since I'm the one changing everything. So and if I go with the first question, that is, if I represent everything as what it is, I still don't have answer there. So none of the above. So let me show the way it is. The way it is square you have there. So even though I do it that way, I only changed it before because I think I have answer there. So this is the s, the t. So I'm taking it back to what it is. So this is speed now, the s, the t. So 3 times 2, 6. So this will be 6t. So at t equals 2, so that means the s, the t is equals to 6 bracket 2. So the s over the t is equals to 12. So that means the s, the t should be 12. That is speed. Then acceleration. So acceleration means you should differentiate the speed again. Remember, acceleration is changing the velocity over time. So if velocity is equals to the s over the t and is equals to 60, then acceleration is the square s over the t square, which is 6. So acceleration is 6. No need of substitution because there is no t. So you see, so none of the above. So like that.